All right, let's dive right into a cosmic detective story. For the better part of 2 decades, we thought we had our culprit, the prime suspect behind one of the universe's most explosive mysteries. But as you're about to see, a brand new piece of evidence has just come in and completely blown the case wide open. So, what's the central question here? It sounds simple enough. What in the universe is powerful enough to create these incredibly intense radio signals, known as fast radio bursts, or FRBs? So, what exactly is an FRB? Okay, I want you to imagine a flash of radio waves coming from a galaxy far, far away. It lasts for just a thousandth of a second, but in that tiny sliver of time, it can outshine entire galaxies. They're so ridiculously bright and unbelievably brief that figuring out where they come from has been one of the biggest puzzles in astronomy for years. Now, for the longest time, the scientific community had a prime suspect. And the theory, the one that really dominated the field, was all about something called a lone magnetar. Pretty much everyone was convinced this was the answer. And you know what? The case for it was really, really strong. Magnetars are these unbelievably dense young neutron stars, and their magnetic fields are literally trillions of times stronger than Earth's. The idea was that starquakes on their surface, or maybe some kind of instability in these insane magnetic fields, would unleash these enormous bursts of energy. And that fit the description of an FRB perfectly. The whole thing seemed to be confirmed in 2020 when we actually saw an FRB come from a magnetar right here in our own galaxy. So, case closed, right? Well, not quite. Because just as everyone was about to close the case file, a new piece of evidence surfaced. A signal that was so strange, so unexpected, that it just couldn't be ignored. And this wasn't just some minor detail. No, this was a game changer. What scientists found was a rhythmic, repeating pattern in these FRBs that just did not fit with the idea of a single, lonely star having random temper tantrums. So who's the new detective on the scene? It's China's 500-meter aperture spherical radio telescope. You can just call it FAST. Its absolutely colossal size gives it a sensitivity we've never had before, allowing it to listen to the whispers of the cosmos with incredible precision. And it was listening very, very carefully. So here's what it heard. As FAST just sat there and monitored these repeating FRBs for a long time, it became obvious their bursts weren't random at all, not even close. They were following a schedule, a clear, repeating pattern that had a period somewhere between 10 and 200 days. This kind of clockwork rhythm is, well, it's basically impossible to explain if your only suspect is a single star acting all on its own. The implication was just staring them in the face. The only thing in the universe that creates such a regular, predictable beat is an orbit. The source of these FRBs wasn't alone. It had to be circling something else. And just like that, we have a new prime suspect. The evidence now points overwhelmingly not to an isolated neutron star, but to a neutron star that's locked in a gravitational dance with a companion star. In other words, a binary system. And this really shows you the massive shift in thinking here. We've gone from a lone wolf model, a single star having unpredictable outbursts, to a dynamic duo model, where it's the constant interaction between two stars in an orbit that actually powers and controls these giant cosmic flashes. This is a fundamental change in how we see these things. And the case for this new binary theory is incredibly strong. It's not just based on one little clue. No, this is built on 4 solid pillars of evidence, and all of it came from the data that FAST collected. Okay, let's just walk through them. Pillar 1, the observation, that high-precision monitoring that showed the patterns weren't random. Pillar 2, the periodicity. The timing of those patterns lines up perfectly with what you'd expect from an orbit. Pillar 3, the interaction. The physics just works, with the stellar wind from the companion star providing all the raw energy needed. And finally, Pillar 4, the emission mechanism. The signal itself looks exactly like something we call a synchrotron maser, which is basically a natural cosmic-scale laser, and that is precisely what this binary interaction would create. But if you want the smoking gun, this is it. Periastron is the point in an orbit where the two stars get closest to each other. And look at this. The data shows that a huge majority of the radio bursts, 3/4 of them, happen right around this point of closest approach. This isn't a coincidence. It confirms that the interaction between the stars is the trigger. So how does this whole thing work? It's basically a 3-step process. First, the neutron star plows right through the stellar wind that's constantly blowing off its companion star. Second, that collision creates these powerful shock waves that act like a natural particle accelerator, revving particles up to insane speeds. And finally, Bam! Those super-energized particles unleash their energy as an incredibly powerful focused beam of radio waves. And that's your fast radio burst. So the verdict is in, and the implications here are absolutely massive. This isn't just about solving one little mystery. It completely rewrites our understanding of what FRBs are and what they can teach us about the universe. You know, one of the things that tells you you're on the right track with a scientific theory is when it doesn't just solve the one problem you were looking at, but it also elegantly resolves a bunch of other nagging puzzles. And that's exactly what the binary model does. I mean, think about it. It explains why so many FRBs repeat. Of course they repeat. The orbit repeats. It explains why we find them in young, active galaxies, because that's where these kinds of binary systems are common. And maybe best of all, it gives us a new lead, a testable prediction. It says we should be able to point our optical telescopes at these spots in the sky and actually find the companion stars that are causing all the commotion. So what this all means is that FRBs are no longer just these weird, mysterious flashes in the cosmic dark. They've been transformed into powerful tools. They're now probes that can give us this unprecedented insight into the physics of binary stars, how stars evolve, and some of the most extreme environments the universe has to offer. And that really leaves us with this tantalizing final thought. By cracking the case of where FRBs come from, we've basically unlocked a brand new way to study the cosmos. So if these bursts are cosmic signposts for these dynamic binary systems all across the universe, what other secrets about gravity, about matter, about the lives and deaths of stars are they just waiting to reveal to us?